All right, what's good, y'all? I'll link here. And I just finished the daily legal questions, so I'm gonna do an extra one. I'm gonna get from the weekly contest 455. So let's get the first question right here and see how this one goes. Okay, extra 3591. Okay, I haven't done this one, so let's see. Also, I wonder if all the questions from the weekly contest, they're always new questions. I think that doesn't make sense, but okay. Let's see. 3591. Check if any element has prime frequency. Okay, so we have a list, oops, a list of numbers. So let's see. Given an integer array nums, return true if the frequency of any element of the array is prime, otherwise return false. The frequency of an element x is the number of time it occurs in an array. Okay, a prime number is a natural number greater than 1 with only two factors, 1 and itself. Okay, so we thinking about the frequency, not the numbers itself, right? So we can kind of ignore this thing and then turn it into a frequency array. So when turning to a frequency array, we'll have something like, okay, so we have 1, which is 1, 2, we have 1, 3, we have 1, 4, we have 2, and then 5, we have 1. So prime, okay, so the return true of the frequency of any element of the array is prime. Okay. Um, so let's see. Okay, I mean, I think this one's pretty straightforward. We just count the frequency of each number, and then we loop over the frequencies and then check if if the frequency is prime or not, or has a frequency of 2, which is a prime number. Okay, so how do we check if the number is prime or not? So primes are what? 2, 3, 5, 7, 11, blah, blah, blah. So I think we can just check if the number is prime if it's let's see, if it's ooh, if it okay, so if the frequency is uh let's see. Okay, greater than one, and only two factor, one self. Okay. I mean, what we can do here is for each frequency, I think we can have the base case. So if the number is equal to 2, and then we return true. If the number is equal to 3, we return true. Else, if we divide the number by 2 and by 3, both modules, the remainder should be different than 0. Right? That means that the number is not divisible by 2, neither by 3. That means it's not even nor odd. So we can just say that the number is prime, right? Yeah. Yeah, I think this was pretty. So we have n is equal to the length of nums. We can have to do frequency count. So frequency count is equal to collections dot counter. Then we do nums, and then we can do values dot values, and then turn this thing into a list. And then for frequency and frequency count, maybe we don't even need to turn into a list. We just need to do the values right here. And then if f is equal to 2 or f is equal to 3, we return true. And then this has to be greater than 1. So if f is equal to 1, we continue. Oh my God, I always do this. Let me get rid of this. We continue, and then else, and then right here we return false, and then we can do is if f mod 2 f mod 2 is not equal to 0, and f mod 3 is not equal to 0, then we return true, I think, right? So if yep, if it's not divisible by 2, neither by 3, we can just return true. And then if it's 2 or 3, those are prime base cases, so we also can return true. If you go to 1, we just continue because we want numbers. Mhm. Oh, yeah, yeah, that's fine. Yep. And then if we go over the whole thing, we don't even do this. Yeah, we do two things. Yeah. Then if we loop over the whole thing, and we didn't find any number that was prime in here, then we just return false at the end. I think it should work. Let's see how this one goes. Yep, give a quick submit. Pretty straightforward one. Um, yeah, I think yeah, it shouldn't be that hard. Just one. Uh, the next one it kind of looks a little intimidating, so I'll probably do that one next. Not sure if I'll do this one today, but yeah, few easy ones in a day. I might, yeah, I'll probably go for this one on the next video. So yeah, I think that's all I have for this one. Appreciate y'all for watching, and I'll see you guys next time.